Okay, so this is the area above the x-axis. Now we want to rotate. So when you rotate, this is actually better. Does it look like a solid? Maybe. As horizontally. Imagine last time we just say, right, pi r squared, because your cross section when you cut this, right, you rotate around the x-axis. This solid, when you cut across, this cross section is actually a circle, right? What is the r? Pi r squared is each cross section. You want to add those slices, disk, become the volume of this whole solid. So we need to take integral of this area, dx, right, from A to B. And this area is pi r squared. And what is r? R is actually this height of f. Does it make sense? So that will become integral pi, put it outside, inside, doesn't matter, from A to B. A squared, r squared. R is your f of x squared dx. Now imagine right now your area is only the green section, not including the pink. So what do we do when you do the solid? Only the green will count, right? So when you rotate that, let's say this is the part I want. When you rotate this part, right, the cross section become like a donut. We call this washer. And how do you find this cross section area? We learned this in geometry. We call this annulus as well. The cross section area is pi, this is the big R, pi r squared, subtract the inner, this small circle, right, minus pi r squared. So that is the area. Does it make sense? So instead of integrating the circle, you are integrating the washer. So that's all it is. Okay. So now represent rectangle is perpendicular to the x of symmetry, right? You want to see if it's revolve around the x-axis or is it revolve around the y-axis horizontally. So if you are going this way, then this is the y value you're going around, correct? So that will be pi y squared dx. If you're going around this way along the y-axis, you are looking at the x value as your r. So the area is pi x squared and then dy, because I'm adding it this way. Yeah? So, okay, so the washer method, it says rotate about the line. The solid is actually with the hole in it. Imagine you're rotating this piece of rectangle, okay? We want to eventually rotate the whole rectangle around. Oh, right now this is, we are not rotating around the x-axis right now. We are rotating around a horizontal line. This could be anywhere. So what happens when you rotate? Sorry, where is my, oof. Okay, I need to draw this myself. So when you rotate this y equals to a, this big. And then inner. See that? So each slice is a washer, and the area, this area right here, how do you find it? You're taking the far end as your radius. And what is the radius? Is the far end, right? Let's say this line is f of x. From the top value goes to that lower value is your r, isn't it? And that is f of x subtract, this is y equals to a. Are you okay with that? It's just the difference of the two values. Take the top minus the bottom. What about the inner radius? Interchange. If this is your g of x, and the distance from the inner near end to that axis, no matter where that is, it could be here, here, x-axis or below, you are taking g of x, subtract a. So each slice, the area is actually pi r squared minus r squared, which is pi. This is f of x minus a squared minus g of x minus a squared. Okay? When we find the volume, watch this. Volume is to integrate this every slice dx. And this is the area of the cross section. Does it make sense? So eventually you're going to have a solid like this, right? With a hole in the cylinder. Okay, next. Oh, there you go. So somehow, when this y equals to a is positive, nobody has any problem with it. If y equals to a is actually below, some students is just like, what? How do I find the big R? Right here. The R is this, right? This is the top value, the higher y value, the lower y value. The distance is the radius. You just need to, let's say, pretend this is y equals to -2. So big R will be equal to what? F of x minus -2. What is minus -2? Plus 2. That will make sense because this chunk is f of x and this is 2 distance-wise. So the radius is f of x plus 2. But it will be less confusing if you can just think, I need to take the top higher value, subtract the lower value to get the radius. Okay? Go. Now, volume practice. Do you guys have calculator? Take calculator out. If you don't have calculator, feel free to use decimals, or you can borrow mine. Who need to borrow a calculator? F of x is absolute value of x plus square root of 1 minus x squared. Do you know how to find the absolute value sign? Is this second window? I can't remember. Calculator.
X equals
going to be very interesting shape.
That was the first period test.
Put it under Y1,
Yeah, and the impact.
and then put the second one, G of X, under Y2.
Yeah, just different events.
Some of the question will provide the graph, some of the question will not. So you have to use your calculator, and then you have to sketch it to see it. Which part is on top, which graph function is at the bottom, where do they intersect, all that. Did you see it? Did you see it? It actually is this shape. I'm so excited. So this is your apple box actually sitting on top. In red, the bottom is G of X. It's a heart shape. So this is the area. Oops, oh, okay. This is the area we want to shade and go around a horizontal line, which is y equals to, what is the line? Y equals to -2. We want to take this and go around y equals to -2 and see what is the solid will form, solid of revolution. Okay. Every time I do this, I just take a chunk. Oops, not very pretty. You take a small chunk of rectangle, and then you go around, right? You go around this y equals to -2. So, right here. Oh, you will see. Oh, it is. Approximately like this. You see that? That intersection, the cross section, is a washer, like a donut, annulus. Oh, it's this. You do it on the side. Okay, now we need to integrate the washer piece by piece. So we will get the entire solid, right? So how do we do that? Find the area for one piece. So you need to find the R. What is that R equal to? The big R is actually, this is f of x, this is -2. Again, top minus the bottom. Okay? So going to integrate pi big R squared minus pi small r squared. And this is the inner radius. So inner radius is actually g of x subtract -2. Should be g of x plus 2. The big R is using f of x minus -2 is plus 2. Now we are ready to, this is dx actually, dx. So we still need to find this limit, right? And limit is where they, well, intersect right here. You know what's the limit? Find the intersection of both. It's actually -1 to 1. -1 to 1. You can take out the pi because that is just the number coefficient, and you can take, this is your y1, right? In your calculator, you can just put in y1, but when you write this, you do f of x plus 2 square, pi r square, subtract pi r square dx. Okay? Anybody have the answer for me? It's all about the calculator. I use the red. So it matches. Anybody? So this should be your F1, Y1, and Y2. All right. Say it again. 15.233. Thank you. All right. Awesome. Let's move on. Times pi. Yes. Okay. This is a common mistake actually. People just so excited to evaluate this part forgot to times pi. What is it?
47.8.
47.8. Is that what you get? 47.3 decimal.
856.
856. All right. Thank you. Very nice. Next. Okay, here is find the volume of the solid formed by the revolving the region about the x-axis. So here, our region bounded by the two function is here. Okay, you want to do that? So here we know that the intersecting points is 0 to, that's probably 1, right? 1. That just set it up. That just set it up. Again, you're going to integrate this chunk around. Sorry, it's too low, but you get the idea. You should have a kind of a donut shape. So we're going to do this chunk, right? Look at one slice. So the area is pi r squared minus r squared integral dx from 0 to 1. We just need to figure out what is the big R, what is the small r, and what do you think the big R is? X squared, yeah, it's not as, this is actually more flat. This is x squared. So that's pi, put it outside, x squared. Don't forget to square. Some students say, oh, it already have the square. R is actually x squared. Square that. And this one was x cubed, the lower one, minus x cubed squared, right? dx. So when we are looking at the expression, you definitely need to write something like this. Limit and pi, probably 1 mark. Integrand is 1 mark, and then the answer is 1 mark, usually. Something like that. Okay, let's move on. If I want you to, if this is a non-calculator session, you should be able to do this as well, right? We already find the definite integral before, so that will be, let's just write it really quick, 0 to 1, x4 minus x, 2 times 3 is 6. You have to integrate x power 4. What is integral of x power 4? x5 over 5 minus x7 over 7, and then you substitute 1, subtract 0. So yeah, since we're already here, let's just finish this up. So that's 1 over 5 minus 1 over 7. Okay, so it's 2 over 35 pi minus 0, right? Minus 0, right that. Cool. And it should be unit cube because you are getting a whole solid here. Okay, let's move on to next. It's right here. Okay, I could have used that. I already did. Okay, next one is go around the y-axis or x equals to a. In this case, you go around the y-axis, so it's horizontal, and your slice is horizontal slice. Yeah. The region bounded by these two graphs. So you see the blue and y equals to 1, right here, y equals to 1, x equals to 1. You have to kind of figure out yourself and revolve around the y-axis. So I'm going around this way, y-axis. So where is my area? The area is here. Bounded by y equals to 1, x equal to 1, and that blue chunk, I'm going over this way. So the bottom here is going to be like this, right? And the middle chunk is going to be like here. Inside there is a hole. There is a hole. So let's figure out what is the outer radius. See? Is from the axis of rotation, which is y-axis, all the way to the outer edge. And what is my outer edge? My outer edge is 1, right here. So the big R is actually 1. Yes? Where is my small r? My small r is from inner edge, inner, to the axis of rotation, right here. This is my inner r. My inner r is this x value, which is the curve. Unfortunately, right now, I'm giving y equals to something x, so I do need to rewrite this expression in terms of x in terms of y. So y minus 1 is x squared, and what is x? X is supposed to be plus or minus square root of y plus 1. Okay, but if it's plus, this is y positive, x equals to positive square root of y plus 1. This one will be negative square root of y plus 1. Oh, minus 1. Oops, sorry. Here. Y minus 1. Y minus 1. My bad. Look at the graph. We are going to take the top one, right? We are going to take the top one. So it's positive. And you are going to take this x, which is on the curve, square root of y minus 1, subtract, well, that is there's no subtract, this is 0. Y equals to, x equal to 0. Now we are ready. Just set up the volume. A lot of times the question says, can you just set up the expression represent the volume of the solid revolution? So integral of pi times, let's put the pi outside, outer, right, r squared, so that will be 1 squared, subtract y minus 1 squared. And be careful, this is what? dy. Where is my limit? The limit needs to go the lowest y value, which is y equals to 1, right? To the top of the y value. And what is that top? Substitute 1 into it, y equals to 2. So I have the lower limit of 1, upper limit of 2. That is, right? Each slice is dy. Let's just clean up a little bit because this is just going to be 1 minus, y squared minus 2y. Oh, wait. Sorry. I wrote it wrong again. This is square root of y minus 1. So it cancel out. The square root and square cancel out. So it's 1 y minus 1. So it's pi from 1 to 2. 2 minus y dy. Okay, I won't do the integration because that's what you're supposed to know how to evaluate already. Now is the concept that's important, how you set up the limit, the integrand, which direction. Okay. Next, what do I have next? Oh, I have that, I forgot I did that. Now, actually, you don't need to go to the board. This is easier than I thought. Just set up the expression. What is the volume if the region enclosed by this two function is rotate about the x-axis? What is volume of the region enclosed by this two function going around the line y equals to 1? So one is the x-axis, one is another horizontal line. Try to set this up. I will try to mirror first. Identify which one is on top, which one is at the bottom. Okay, who want to try? What is the volume? Energy is a little low. Cindy?
Pi times integral of 0 to 1.
0 to 1.
Is it?
What do you mean 0 to 1? I want the integrand. Oh, 0 to 1.
Yeah,
I thought
yeah,
this,
yeah.
oh, yes. 0 to 1.
And then root x, no, square root x minus x squared, whole thing squared.
Oh. No. Are you saying this? Are you saying this?
Yeah.
Ah, watch it. This is incorrect. What did you do here? You take y. That's what you did, yeah? We don't want that. We want what?
R.
Separate. Pi r squared, bigger circle, subtract the small circle. That's different. I'm glad you actually did it because a lot of students did that too, just by accident. I know you understand, but when you write it, yeah, you have to do individual. Square root of x square, subtract x square, yeah. Okay, the other one looks actually the same thing, don't you think? But we are going to revolve around y equals to 1. If I turn this around, isn't that similar to that? It just kind of flipped. So this is like a shift. So I'm just looking at the outer edge of the curve to the axis of rotation. So this distance should be also what? Okay, sorry. I should go from here. See that? This is actually my r. So, are you looking? Now my top value is actually 1. So r is actually 1 minus this is the lower one, lower end, right? X squared. And the inner radius is 1 minus square root of x. And what is my limit? My limit is also from 0 to 1. Okay, we're going to go around. So, you can just set that. Okay, we were working on this question. So this shaded area go around the vertical line, x equals to -1. So you need to look at horizontal distance. horizontal distance is how far the x change. So look at the outer curve. From the outer edge to the axis of rotation. So find out what is x1, subtract -1 is your outer arc. So we kind of rewrite this expression, x equals to something y, yes.
So you put the dx at, where do you dx or would it be dy?
It will be dy, thank you. This is actually dy. Why? Because this is the lower y to the upper y. Thank you, Elliot, for catching it. And then the inner r is actually, look at the radius here, is the inner edge which comes from the function here. And we try to find what x is in terms of y, right? So x2 is y1 minus 1 over 2. So the radius is distance of x2 minus -1 is x2 plus 1. So same thing, pi big R square minus small r square. Your big R is here, all right? And your small r is dy.
How do we determine the limit?
Say
How
it
do we
again.
determine the limit?
How do you determine the limit? Usually you find their intersecting points,
Oh, okay.
right? Find the intersecting points of the two curves. By going around this way, I need to find lowest y to highest y. If I rotate around the x-axis, I want to find the small x to the biggest x. Okay, so that is the lesson.